Moving to the Morb mid-oceanic ridge basalt. So Morb, you can say Morb is the most voluminous rock in the earth crust. Okay, Morb is the most voluminous rock earth crust. Most voluminous. Okay, voluminous. So almost entirely the oceanic crusts are the upper oceanic crust, upper part of the oceanic crust is almost filled with the morb. Na, earth surface, you can say earth surface. Morb is the most voluminous rock in earth surface. Na, so basically morb is directly formed, or you can say just basalt. Basalt is directly formed from the partial melting of mantle material. Mantle material. Okay, partial melting of mantle material. Basalt is directly formed from partial melting of mantle material. Now, thing is how morb is generated. Okay, how morb is generated. So basically, you know the process. You know the plate tectonics thing that first the rifting occurs. Okay, a plate rips from the बीच में से वो टूट जाता है ठीक है आफ्टर रिफ्टिंग what happens the pressure the lithostratigraphic pressure over the magma over the mantle materials is released na? So after the lithostratigraphic pressure is released over the mantle material, so the melting point of the mantle materials will decrease or increase. डिक्रीज ना दोस्तों तो mantle जब प्रेशर जब ज्यादा होता है तो मेल्टिंग पॉइंट भी उतना ज्यादा हो जाता है प्रेशर जब घट जाता है मेल्टिंग पॉइंट इज ऑल्सो decreases. Okay, so that's why in high lithostratigraphic pressure, this is your crust, this is your crust, and this is your mantle. Consider this is your mantle or upper mantle or lower mantle, the whole mantle you can say. Now this continental crust is around 33 kilometer thick. This thing is this continental crust is generating a pressure over this mantle material. Okay, now this mantle is semi-solid, you know, or you can say solid capable of flowing. Okay, now what is happening when this crust gets fractured and separated, gets rifted, then the pressure over this material is released. So now the melting point of this material will decrease, and these mantle materials will be melted easily because the melting point decreases. Okay, now the thing is this mantle material will be started melting. Okay, this is called as decompressional melting. So decompressional melting. Okay, decompressional melting. दिस इज कॉल्ड एज डीकम्प्रेशनल मेल्टिंग कंप्रेशन था डीकम्प्रेशन हुआ और मेल्टिंग हो गया ठीक है नाउ द थिंग इज दिस डीकम्प्रेशनल मेल्टिंग डायरेक्टली चैनलाइज ए पाइप और यू कैन से डायरेक्टली चैनलाइज ए like a way like a path to the mantle okay like a path to the mantle so now this mantle material will start melting or the mantle material coming from the below that will also the convection current na the convection current is going on the convection current is going on so now the convection current is as the convection current is going on now the thing is it may be the upper mantle material or maybe the lower mantle material because the convection current is going on more with the rock which like proves that there is a convection okay more is the rock which proves there is a convection because in morb it may come from the upper mantle it may come from the lower mantle because the convection is going on na? Convection is going on so now this is rifted zone okay this is the rifted zone now this is the like your mantle okay this is your lower mantle and this is your upper mantle. This is your upper mantle. Now the convection is going on. Convection is going on. Okay, now the thing is, this like erupting lava, this erupting lava may be of the upper mantle or maybe of the lower mantle because of convection going on. If it taps the upper mantle, we say that it is as N more. Okay, N more. And if it taps the lower mantle, means it comes from the lower mantle, then it will be called as E more. Okay, E more. Now tell me one thing. The upper mantle is enriched in incompatible elements, or the lower mantle is enriched in incompatible elements. Yes, the lower mantle, because the lower mantle is already a primitive magma or a primitive material, but the upper mantle is highly fractionated from the origin of Earth. Now, upper mantle is continuously undergoing fractionation, continuously undergoing fractionation. Okay, that's why upper mantle is totally depleted in the REs or LILEs, HFSEs, these elements. Okay, but the lower mantle is highly enriched in these elements. So now the thing is, when this morph taps the upper mantle or comes from the upper mantle, this N morph will be depleted in nature. But in the same case, E morph will be enriched in nature. Enriched in nature. Uh, Getting this, na? So N morph will be depleted. So this is called as normal morph. Okay, and this is called as enriched morph. N morph, E morph. So morph has basically two types, N morph and E morph. Okay. Yes, Ankita. Okay, now tell me one thing. Water content. Water content. So you already know that the there is a paper, research paper on this water content. There is जितना भी वाटर अर्थ में है ना तो उससे कहीं ज्यादा वाटर हमारा mantle में है, यू नो दैट। यू हैव तुमने कहीं सुना होगा ऐसा कुछ, ठीक है। उसमें एक पेपर आया था, उसके ऊपर mantle क्यूमुलेट्स एंड हाइड्रोस कंटेंट के ऊपर एक पेपर आया था कि हमारा ओशियन ओशियन में भी जितना पानी है उससे भी कहीं ज्यादा गुना पानी mantle में है, ठीक है। बट दिस इज नॉट इन द वाटर नेचर, दिस इज एसोसिएटेड विद द एलिमेंट्स। ओके, so this is not like in the ocean form. So you know that N more is hydros or E more is hydros, anyone? So basically, I am telling that a upper mantle is hydrous in nature or lower mantle is a hydrous in nature. I am asking that. Yes. So the lower mantle has more hydrous content, okay, than that of the upper mantle. You can say E morph is E morph has higher H2O content, okay, because it taps the lower mantle, and N morph has lower H2O content. Okay, lower H2O content. ठीक है। Okay, so this is the basic difference between E morph and N morph. Other differences are there. We'll see in the slide. And you, yes, Kostur. Your E morph is hydrous in nature. Okay, E morph is hydrous in nature, or you can say higher H2O content, and N morph has lower H2O content. Okay. Apart from that, other things are there. We'll see in the slide. Okay, you already know. So I have taught you about the petrogenesis of basalt, morph, and the basic classification about N morph and E morph. Apart from that, you already know what is the composition of basalt. Anyone, what is the composition of basalt? Go to the slides and see what I have left. So most voluminous volcanic rock in are produced by fractional crystallization within magma chamber formed under reducing conditions. Okay, this is in the formed under reducing conditions. So basalts basically are reduced in nature. Okay. So plutonic equivalent of gabbro-diorite anorthosite, and there is no plutonic equivalent of anorthosite. Okay. Petrogenesis, I have already told you, separation of plates, upward motion of mantle material, decomposition or partial melting associated with neo-adiabatic rise. Okay, so this thing you know, all the rises from mantle are neo-adiabatic in nature. Okay, neo-adiabatic in nature. What is adiabatic? Adiabatic relates to constant energy, and heat is a energy. So it is a energy. So adiabatic rises, although uprises from the mantle, is of constant heat in nature. That means it does not exchange heat with the सराउंडिंग मटेरियल. जो भी राइज होता है मंटल से नियर एडियाबेटिक रहता है. व्हाई नियर एडियाबेटिक? व्हाई नॉट फुल्ली एडियाबेटिक? क्योंकि क्योंकि हाँ, यस, that is, it is not a closed system actually. Okay, the rising, the mantle rising is a, the plume rising is not a closed system ना. तो वहाँ पे मटेरियल एक्सचेंजेस होते रहते हैं. ठीक है, असिमिलेशन डिफरेंशिएशन होता रहता है. ठीक है, सो दैट्स व्हाई इट इज नियर एडियाबेटिक. So it is not a closed system. So this is the near adiabatic rise. And N-more melting initiates 60 to 80 kilometer depth, that is in the upper mantle. Okay, and depleted in trace elements. E-more plume is initiated with the lower enriched mantle. Okay, N-more types of upper mantle, lower mantle. Mores are more homogeneous than OIB and subduction. Okay, mores are more homogeneous in nature than that of OIB and subduction zone magmas, because more directly comes from the mantle. Okay, directly it is a open area for the mantle to come out. But in case of OIB or in case of subduction zones, it undergoes assimilation and differentiation process. Okay, that's why more is more homogeneous than OIB and subduction zone magmas. Okay, so the difference between them are the, okay, petrography dominant phenocryst is olivine. Only more evolved have CPX, तो पाइरोक्सिन ज़्यादा नहीं होता. ठीक है, जो जितना जितना अगर ज़्यादा इवॉल्व हो जाता है, मतलब ज़्यादा डिफरेंशिएशन हो जाता है, देन सीपीएक्स आएगा. So primitive lava composition is high MgO and most Fe4 tholeiitic basalt. So these are Fe4 tholeiitic basalt. That's why the dominant phyllocrest is olivine na. Okay, so this is the difference between E morph and N morph. This is depleted, this is enriched, lower H2O content, higher H2O content, higher Fe and lower aluminum and lower Fe. Okay, upper mantle, lower mantle, Mg number is greater than 65. This is also Mg number greater than 65. Keto content is low, keto content is high. Basically, E morph is enriched one na. So all the incompatible will be enriched in this E morph, but all the compatible will be enriched in the N morph. Okay. So like that, TiO2 and lanthanum by samarium and lanthanum by samarium. Can you tell how this lanthanum samarium is less for N-morph and for this is greater for E-morph? The samarium content, na? The samarium content. Why this samarium content is likely high? It is samarium content is likely low. So I have already told you that mantle is higher in samarium neodymium content na. So when we are telling about mantle, okay, the lower mantle is enriched one. Okay, the enriched one. So the upper mantle is a depleted one. So samarium lives there where depletion is more na. Samarium lives there, so samarium will be in the N more or in the upper mantle portion. ठीक है. सर लांथानियम समारियम लांथानम समारियम इसके लिए लिखा है हुआ है क्योंकि ये जो दो बात हो रहे हैं ना, एनमोर्फ एंड ईमोर्फ, दिस डिवीजन इज बेसिकली ऑन द like incompatible element enrichment. Okay, that's why lanthanum and samarium, because lanthanum and samarium has exactly opposite characteristic na. All the incompatible elements, all the, like you can say, all the Re elements are one side, and this samarium and neodymium are in the other side. Okay, because elements enrich in the crust, but samarium neodymium उसका अलग ही चलता है भाई, वो mantle में ही रहेगा. Okay, that's why that this enrichment thing is there now between, classified between N-morph and A-morph. That's why we have compared lanthanum and samarium. Okay, तो samarium का अलग ही चलता है, वो बस mantle में ही रहेगा, वो उसको क्रॉस का नहीं आना है, वो आ रही है फिर भी वो क्रॉस का नहीं आएगा. ठीक है, तो that's the thing. So N-morph defines isotopic end member of terrestrial volcanic array characterized by low, obviously low strontium and high neodymium ratio. That's one I am telling you. I was telling you high samarium means high neodymium ratio. Okay, indicating their source has experienced long-term depletion in RB and SM. Okay, this interpreted to be a signature of convecting asthenosphere. तो ये जो सिग्निफाई करता है, एन मोर्फ ई मोर्फ दोनों के लिए ये लिखा हुआ है, ऐसा नहीं कि एन मोर्फ के लिए, मतलब ये डाटा के लिए ये नहीं है. ठीक है, ई मोर्फ एंड एन मोर्फ दीज शोज कन्वेक्टिंग आस्थेनोस्फीयर. क्योंकि क्यों क्योंकि हम लोग ई मोर्फ भी मिल रहा है सेम जगह में और एन मोर्फ भी मिल रहा है. ठीक है, तो उससे होता क्या है कि हम लोगों को पता चला कि mantle जो है वो कन्वेक्शन में है, जिसके वजह से एन मोर्फ भी आ रहा है और ई मोर्फ भी आ रहा है. ठीक है, ओके, दैट इज ऑल अबाउट. See what is comatite. See